Hello friends, in this second part of geometrical modeling lecture, we'll see geometrical modeling. We have discussed about wireframe. Okay, now we'll see what is surface modeling, then again solid. Fine. Now surface modeling, as I said, it is wireframe becomes the base for this particular surface modeling. Okay, in surface modeling there are many types. For example, if I consider a box of this kind, now this box has been developed by using different surfaces, maybe S1, S2, S3, S4, S5, S6. So to develop a box, I need to have 6 surfaces. Whereas in the earlier case of if you consider a wireframe model, you have to consider V1, V2, V3, V4, V5, V6, V7, V8. Okay, so you need to consider 8 vertices or vertex. Okay, to develop a wireframe model. Hey, this is the case. Okay, now 6 surfaces are required to develop a surface model. Again, this is also not a complete representation. Here there might be few problems, but this type of modeling is also required in case of automobile or aerospace engineering. The application point, if we'll talk about a surface modeling, we can call it a sheet metal work also, is aerospace industry and automobile industry basically. Okay, other than this there are many other ways, in core industry, like to develop a boiler. In many other cases also surface modeling will help. Okay, now this surface modeling is of many types. Okay, number one is plane surface. Now the plane surface is represented something like this. This is the representation of a plane surface. Okay, it is not compulsory that it need to be a exact rectangle or exact square. Okay, if I try to add surface in between two lines, okay, it is going to be linear. It is going to be linear, something like this. Okay, plane surface, simplest surface required. Okay, this required some control points, that's it. Fine. Now if you consider the second one is a ruled surface. Now you can draw all these in a software called AutoCAD. Okay, in AutoCAD, ruled surface is called as RUL surf. This is the command which can be given in the command prompt to attempt this option. If I'll say RUL surf, it will ask me options, starting point, which is the ending point. Okay, now for this, on a graphic window, on a AutoCAD graphic window, I need to draw 2 curves of this kind, maybe, or any other 2 curves with some offset distance. It should maintain some distance between. Okay, if I'll say rule surf, it will ask me to pick the functions. If I consider this as the first function, this as the second function, I have to pick one after the other, and the function is denoted something like this: C1 of u, this is first function, C2 of u is your second function. Okay, the system will understand this language. Okay, this is considered as first function, this is considered as second function. Once I say RUL surf, it will ask me to select the first function. If I pick this point, corner point, then it will ask me the second function. If I pick the second corner, the surface is going to be something like this. It will develop automatically this particular surface, followed by curves, something like this. Now you can control this horizontal and vertical lines. You can increase the mesh size also, or you can decrease the mesh size also. You can increase number of horizontals and verticals to make the surface more effective. Okay, it all depends on the requirement. Fine, this is how we'll do. For example, if the same surface, C1 function and C2 function, if I pick this point, followed by, if I pick by mistake, if I pick this particular point, second selection, the complete surface is going to be twisted. It will twist from one side to the other, something like this. It will become completely twisted, zigzag. Okay, the selection should be proper. Okay, for this plane surface also, the command in AutoCAD is PL surf. Okay, PLN surf. Okay, similarly, the third one is surface of revolution. This is the third one. Okay, to do this surface of revolution, you need to have a open profile followed by an reference line or an axis line. Okay, now we consider this as the profile followed by an axis. Now if I'll say revolve surf, REV surf in AutoCAD, in the command prompt, revolve surf, if I type, I'll get revolution surface. Okay, now followed by select the profile followed by the references. Okay, if you select these two, this profile need to be rotated. It will rotate with respect to the axis line to get a symmetrical object. The maybe something like this. Okay, and the arrangement, the sketch is going to be like this. The object will look something like this. Now this will rotate with respect to the axis 360 degrees. Okay, you need to give the angle also, 360 degrees rotation or 180 degrees rotation. Accordingly it will rotate and it will give you a surface. And it is not a solid again, it is just a surface. If you view from the top, bottom is visible completely. If you pour something inside, it will come out. Okay, it is open completely, hollow. Fine. This is it is a surface of revolution, which is third one, and fourth one is tabulated surface, and the command is tab surf in the command prompt in AutoCAD. Once you say tab surf, it will ask you to select the profile followed by the direction. Okay, so before you type this tab surf, you need to have a profile followed by direction. Okay, now profile has to be drawn in one plane and direction has to be drawn in a plane which is perpendicular to the plane where you have drawn the profile. Okay, and the length of the direction line going to be the surface length. Okay, if you increase this length, surface length will also increase. Okay, once I say tab surf, after drawing these two, it will ask me to select the profile. This is the profile, open profile, and followed by the direction. Once I will select the direction, now the surface will form this way. This is how the surface will form. Okay, followed by a line. Fine, this is surface you will get. Okay, tabulated surface. Now this option is similar to sweeping in case of solid modeling. When we discuss solid modeling, we will talk about sweeping. We will try to correlate both of them, which will make the subject more easy and comfortable. Fine, and this surface of revolution also related to solid modeling, where you have an option called revolve. Okay, there we will try to use a profile which is closed. Here we will use a profile which is open. Fine, all these are almost correlated to each other options. Okay, then after this you have one more surface called Bezier surface, number 5, Bezier surf. Okay, in these surfaces you have a surface called Bezier. We have already discussed what is Bezier. Is an approximation curve in case of wireframe modeling. In case of wireframe modeling also we have Bezier, B-spline, cubic spline, where the same things we have in surface modeling also, but here it is Bezier curve. In case of surface modeling, it is going to be Bezier surface. Okay, it will take the approximation control points to form a surface. Okay, similar to a curve, it does not. Now for example, here is one control line, here is another. The surface is going to be something like this. In this case also, similar to the wireframe, Bezier curve will not pass through all the data points. It will not pass through all data points. Okay, means again it is an approximation surface. Okay, similarly 6 surfaces we have B-spline surface, B-spline. Okay, again B-spline surface, the way we have discussed, there will be a local control of the surface that is possible. Okay, now again these two are called as synthetic surfaces. Again we have a flexibility, like the curve can be controlled something like this. The two curves may not be of same shape, but still we can make a surface followed by. Okay, now here in B-spline we have approximation and interpolation, both types. Okay, in approximation nothing but where it may not pass through all the data points, whereas in interpolation it will pass through all the points. Okay, now these Bezier and B-spline are called as synthetic surfaces. The way we have discussed in wireframe, those two are nothing but synthetic curves. Okay, in a similar fashion. Fine, other than this 6, 7th one is, there is one more surface called Kuhn's patch. Okay, now this is used to help, this will help you when you have a closed boundary. For example, now the boundaries, already existing surface boundaries are there. For example, these are the already existing surface boundaries. Okay, now this gap can be filled with the help of a surface called Kuhn's patch. This gap can be filled. Okay, maybe this is a different surface and this is a different surface. 1, 2, 3, 4, 5, all 5 surfaces are linked and there is a gap after joining them all. Now this gap is completely closed with a boundary. Okay, that boundary, closed boundary, can be closed with the help of Kuhn's patch. Other than this, you have a surface called fillet surface. Okay, and a surface called offset surface. Okay, fillet surface nothing but, for example, if you have 2 plane surfaces of this kind, 2 plane surfaces. Okay, now these 2 plane surfaces are maintaining 90 degrees, the edge is maintaining properly. Now this sharp edge can be avoided by using fillet surface. If I will say fill surface, it will ask me the radius. If I give 5 or 10 radius, then here a fillet will be formed. Okay, now I can avoid the sharp corner with this fillet. Now the side view going to be something like this. There won't be any sharp corner, we can avoid this with some radius. Okay, offset surface again, already existing plane surface or any other surface is there. If you want to make a copy of it, if you want to make n number of copies of it, for example, in this direction with an offset distance of 10 mm, I want some 20 similar kind of planes, 20 number. Okay, that can be done by using offset surfaces with an offset distance of 10 mm with 20 in number or 1000 in number or 100 in number. That can be done by using this offset surface method. Okay, again, now these are all, for example, we have some 9 out of this: Bezier surface, B-spline surface and Kuhn's patch. These are synthetic surfaces. Now when we talk about complete analytic type of surfaces and synthetic type of surfaces, we'll try to know the equations. We'll try to write the equations for B-spline, Bezier and for maybe for plane surface, ruled surface. Okay, we'll discuss all the equations related for plane surface, ruled surface and all other surfaces in the next upcoming lecture. When you go in depth of surface modeling, we'll try to discuss all of them in a fresh lecture. Okay, this is all for now. This is all about surface modeling. In the part 3 of geometrical modeling, we'll talk about solid modeling, which is the complete representation of a model. This is all for now. If you have anything to ask, you can comment in the box given below. Thank you for now.